Welcome to this video presentation by the postgraduate student whose poster it represents. We will miss the bustling crowds around the posters at the All Energy Conference this year, but we hope you enjoyed this online version that we have created. Before the presentation starts, I would like to acknowledge the support of our generous sponsors. Without this support, the competition could not proceed and the winning entrants would not receive a financial award. Our platinum sponsor is the Victorian Government through the Department of Environment, Land, Water and Planning. Its brands include Victorian Energy Compare, Victorian Energy Saver, Victorian Energy Upgrade Program, Energy Scorecard and Energy for Business. Their contact details are on the slide. Monash University's Monash Energy Institute is one of our silver sponsors. With over 170 staff involved, the Institute has a vision to bring people together to solve global energy problems. The Monash student posters in this competition represent some of that work. Baywa Renewable Energy is another silver sponsor. Baywa develops both wind and solar projects in Australia as part of a global energy portfolio. Baywa staff have also supported our AIE events in the past, including our Young Energy Professionals Speed Networking events. Our final silver sponsor is the University of Melbourne's Melbourne Energy Institute. Many of you will have attended their regular forums that keep the energy community and public up to date on technical and policy energy matters, and the University of Melbourne posters in this competition reflect some of that work. Seed Advisory is our bronze sponsor, and this small but well-recognised energy consultancy covers both the technical and regulatory fields. Seed Advisory has been a regular supporter of the AIE and a presenter at our events. Lastly, we thank All Energy for hosting our live poster events over the last decade, and we look forward to doing this again post-COVID. These last slides show you our poster winners in the last competition. And I now hand you over to the poster presentation. Thank you.
Hi everyone, my name is Angela and I am a student at the University of Melbourne. Today I'll present the work related to phase grouping of residential customers using smart meter data. This work has been done in collaboration with my professor Luis Nando Ochoa from the University of Melbourne. And before starting, I would just like to thank the organizers for giving us this opportunity for this year's poster competition. With the fast implementation of distributed energy resources in Australia and all around the world, there have been a lot of challenges for low voltage distribution networks, such as voltage rise due to the photovoltaics and voltage drops due to the electric vehicles. Therefore, adequate three-phase low-voltage models are needed to carry out any type of analysis involving distributed energy resources. However, one of the major challenges in producing these models is the absence of knowledge about the phase groups to which residential customers are connected to. That's why this work proposes an approach that is able to determine the phase group to which each customer is connected to in a given low-voltage feeder without having any knowledge about the phase groups for some of the customers. The proposed phase grouping approach consists of 5 sequential steps. The first 3 steps are done for each of the days of the investigated historical data, for instance, a week or a month. Once all the days are analyzed, the last 2 steps take place. In the first step, the pre-processing of customers' data is performed. The voltage time series data of the customers, fed by the same feeder, is imported and normalized. In the second step, a feature reduction method named Principal Component Analysis, or PCA, is used to extract the main features of the voltage time series data. The first 2 principal components from the PCA are selected and used as coordinates representing each of the customers. Then, in the third step, an unconstrained K-means clustering technique sorts the customers in 3 clusters according to their similarities. It's called unconstrained because it doesn't have any constraints or any information about the topology or the phase groups for some of the customers. It divides the customers into 3 clusters by calculating the distances between the centers of the clusters and each data point representing a customer. Then, after multiple days are analyzed, in the 4th step, a phase group linking algorithm is used to link each of the 3 clusters identified in each day to a consistent phase group. Finally, a statistical assessment is performed to determine the most predominant phase group for each customer. Or, customers are allocated to the phase group that is more frequent. The performance of this approach is demonstrated on a realistic Australian low-voltage feeder with 31 single-phase customers, considering 1 and 2 weeks of voltage time series data with 30 minutes resolution per each season for each of the customers. In order to thoroughly assess the proposed approach, multiple cases are investigated considering the presence of PV system and the period during the day from which voltage measurements are considered, such as the whole day, high demand, and low demand hours only. The tools used were the Open Distribution System Simulator and the programming language Python. The results show that there is no difference between the results obtained for 1 week and 2 weeks of historical data per each of the seasons. Also, the proposed approach shows equal accuracy whether the high demand or low demand hours are used. Therefore, it doesn't need to include the whole day of measurements. It can show 100% accuracy by only taking the high demand or low demand hours. So this brings us to the conclusions that the proposed phase grouping approach gives accurate results for the investigated realistic low voltage network with no predefined phase groups for some of the customers. Still, further research is needed in order to check the implementation of this algorithm for different feeders in different low voltage distribution networks, as well as how well will this work if only 2 phases were the most used. Thank you so much for your attention.